Tonight, we are going to spend some quiet time beneath one of humanity's oldest companions, the night sky. There is nowhere we need to hurry, nothing we need to solve before morning arrives. The stars have waited for billions of years, and they will continue their patient journey long after this evening has gently passed. For now, it is enough simply to imagine standing beneath them, breathing slowly beneath a sky that has always belonged to everyone who has ever looked upward. Long before observatories crowned mountaintops, before glass lenses magnified distant worlds, before mathematics carefully described the movements of planets, there were quiet nights like this one. There were open plains where the wind crossed dry grasses without interruption. There were deserts that cooled after the heat of day. There were forests where branches framed small patches of starlight, and coastlines where gentle waves reflected the moon with every patient rhythm of the sea. In every age, darkness arrived not as an ending, but as an invitation to notice what daylight gently concealed. Ancient astronomy did not begin inside great buildings. It began with ordinary people lifting their eyes after sunset. Shepherds watched over sleeping animals. Sailors rested on calm waters. Farmers waited for the changing seasons. Children listened as elders pointed toward familiar constellations whose shapes had been remembered for generations beyond counting. Above them, the stars followed paths so gradual that they seemed almost perfectly still. Yet, over the course of every night, they moved with quiet certainty from horizon to horizon, tracing invisible circles around the sky that rewarded anyone patient enough to notice. The earth itself was turning beneath those silent observers, although no one yet understood that remarkable fact. To them, it appeared that the heavens slowly revolved overhead like an immense celestial sphere, carrying thousands of distant lights across the darkness. Sometimes understanding begins simply by watching carefully. The earliest astronomers possessed no telescopes, no cameras, and no computers. Their greatest scientific instruments were memory, patience, conversation, and the remarkable ability of the human mind to recognize patterns across months, years, and generations. A child might notice where the moon rose. An elder might remember where it had risen decades earlier. Together, those quiet observations became knowledge. The sky encouraged a kind of thinking that unfolded slowly. Nothing rushed. A single question could remain open across an entire lifetime. The stars never seemed offended by uncertainty. They simply continued appearing night after night, allowing careful observers to return again and again. There is something deeply comforting about a universe that does not hurry us. As your thoughts gradually settle, imagine an open landscape thousands of years ago. The air has become cool after sunset. A small fire glows gently nearby, its warmth reaching only a short distance before giving way to darkness. Beyond that circle of light stretches a world filled with quiet sounds, distant insects, a soft breeze, perhaps the slow movement of water over smooth stones. Above everything shines an endless sky. Without city lights, The Milky Way appears as a pale river stretching from one horizon to the other. Countless stars blend into a soft, luminous band that ancient observers often imagined as a pathway, a flowing stream, or the lingering smoke of celestial fires. Today, we understand that this glowing arch is the combined light of hundreds of billions of distant stars within our own galaxy, viewed from inside its broad spiral disk. Knowledge has changed the explanation. It has never diminished the wonder. Long before written language became widespread, stories carried astronomical knowledge across generations. Certain stars announced the coming rains. Others signaled colder nights or warmer seasons. The sky became a calendar written not with ink, but with light. Every clear evening offered another opportunity to read its familiar pages. Different cultures imagined different figures among the same stars. Some saw hunters. Others saw birds, rivers, fish, or great trees whose branches reached across the heavens. These interpretations varied widely, yet the stars themselves remained quietly unchanged, allowing countless civilizations to discover meaning without altering the sky itself. Perhaps that is one of astronomy's gentlest lessons. The universe can be shared without needing everyone to describe it in exactly the same way. Slowly, over generations, people noticed that not every light behaved alike. Most stars held steady relationships with one another, preserving familiar patterns throughout the year. Yet, a handful wandered slowly against the background. These unusual objects became known, much later, as planets, from a Greek word meaning wanderers. Mercury lingered close to the horizon. Venus shone with extraordinary brightness before sunrise or after sunset. Mars glowed with a quiet reddish light. Jupiter moved patiently across the constellations. Saturn drifted even more slowly, requiring many years to complete its circuit. Without instruments, ancient observers recognized each of these worlds simply by paying attention. Careful observation often reveals extraordinary things hidden within ordinary evenings. Far away from one another, civilizations separated by mountains, oceans, and centuries gradually built their own traditions of astronomy. Along the Nile, seasonal stars helped anticipate the annual flooding that renewed fertile farmland. Across Mesopotamia, generations of observers recorded celestial movements with remarkable consistency. In ancient China, careful records preserved observations of comets, eclipses, and unexpected stars. Across the Americas, communities aligned buildings with the rising sun and changing seasons. Each tradition reflected its own landscape, its own climate, its own questions. Yet all of them shared the same sky. And under that shared sky, humanity slowly learned that patience can become a scientific method. Night after night, the same gentle procession continued overhead. Although each evening seemed much like the one before it, careful observers gradually realized that the sky possessed rhythms nested within rhythms. The stars returned to familiar places with remarkable reliability, while the moon wandered through changing phases, and the wandering planets traced slower paths that unfolded over months and years. What first appeared simple slowly revealed itself to be richly patterned, rewarding those who were willing to notice small differences over long stretches of time. The moon was perhaps the most intimate companion of ancient astronomy. Unlike the distant stars, its appearance transformed continuously. A thin crescent rested quietly above the western horizon, then gradually grew into a bright half circle, and later into a full disk that illuminated forests, rivers, and empty deserts with a soft silver light. Afterward, it slowly diminished again, returning almost invisibly toward darkness before beginning another cycle. Current measurements show that this familiar journey takes just over 29 and a half days from one new moon to the next, a rhythm that quietly shaped some of humanity's earliest calendars. Imagine an evening thousands of years ago beside a slow-moving river. The day's work has ended, and the water reflects the moon with gentle ripples that stretch its image into shimmering silver lines. Nearby, reeds sway softly in the breeze, while insects continue their quiet conversations hidden among the grasses. Someone sitting beside the water marks another small notch onto a piece of wood or bone, keeping count of the moon's steady return. The action is simple, almost ordinary, yet over many months it becomes a record of remarkable precision. Science often begins with ordinary moments repeated patiently. Elsewhere, high above broad valleys, another observer watches the horizon rather than the moon itself. Certain stars always seem to rise from nearly the same places, while others disappear for part of the year before quietly returning. As the seasons change, different constellations slowly take their places overhead. The sky itself becomes a dependable companion to the passing of time, gently announcing the arrival of planting seasons, migrations, colder winds, or warmer days. No single night reveals this larger pattern. It emerges only through memory. The earth continues its silent journey around the sun, although ancient observers could not yet know this hidden motion. From their perspective, it seemed that the heavens themselves slowly shifted through the seasons. Modern astronomy explains these changes through the movement of our planet, but the observations themselves were already astonishingly accurate. Long before the underlying mechanics were understood, people had carefully described what they could see with their own eyes. Understanding often grows in layers. First, we notice. Later, we explain. The stars remained patient through both stages. Over countless generations, certain places became favored locations for watching the heavens. A hill with an unobstructed horizon, a broad desert where dry air offered unusually clear nights, a quiet shoreline where the sea met the sky without interruption. These landscapes asked very little of those who visited them. They offered space, silence, and an uninterrupted view into great distances. In such places, darkness was never empty. It was filled with detail. The Milky Way slowly arched overhead like pale mist, suspended across the night. Today, astronomers understand that the faint glow comes from enormous numbers of distant stars, whose individual light blends together beyond the ability of human vision to separate them. Ancient observers naturally imagined rivers, roads, trees, smoke, birds, or celestial pathways. Each interpretation reflected familiar experiences upon Earth, while quietly acknowledging something much larger beyond it. There is comfort in discovering that imagination and observation can exist side by side. Far to the east, before sunrise, a particularly brilliant point of light begins to emerge above the horizon. It is Venus, shining more brightly than any other planet visible from Earth. Ancient civilizations noticed its dependable appearances with great care. Sometimes it greeted the dawn. At other times, it lingered after sunset. Although they did not yet understand that both appearances belonged to the same neighboring planet, many cultures carefully tracked its changing schedule over many years. Venus rewards patience because its cycle unfolds more slowly than everyday experience. It asks the observer to remember seasons rather than hours, years rather than days. Some knowledge arrives only for those willing to wait. Meanwhile, clouds occasionally covered the sky for many evenings at a time. Rain softened the ground. Mist drifted through forests. Winds carried changing weather across mountains and plains. Ancient astronomers could do little except wait for clearer nights. Their work depended upon conditions beyond their control, reminding them that observation was always a quiet partnership between human curiosity and the natural world. Even the most careful observer cannot hurry the clearing of clouds. Perhaps this, too, shaped the character of early astronomy. It encouraged patience instead of urgency, acceptance instead of frustration. If tonight's sky remained hidden, another night would eventually come. The stars would return exactly where careful observation expected them to be, as though they had simply been waiting behind the passing weather all along. The universe has never demanded constant attention. It has only invited us to return. Across many parts of the ancient world, elders shared their knowledge not through books, but through conversation. A child might learn that a certain bright star appeared just before the harvest. Another constellation might signal the return of migrating birds. The moon's shape might suggest how many nights remained before an important gathering. These lessons blended practical observation with family memory, until astronomy became woven gently into daily life. Knowledge spoken beneath the stars often carried a different feeling than knowledge written upon a page. It was surrounded by cool air, quiet voices, and long pauses between sentences. Perhaps that is why so many ancient stories lingered. They were learned not in haste, but beneath skies that naturally encouraged careful listening. Slowly, the generations changed. Children became elders. Observers became teachers. Questions passed quietly from one lifetime into the next. And above them all, the constellations continued their patient journey across the darkness, asking for nothing more than another clear evening and another pair of thoughtful eyes turned gently toward the sky. The stars do not reveal everything at once. Even under the clearest night, much of the sky appears almost unchanged from one hour to the next. Only someone who remains quietly awake, watching with patient attention, begins to notice the gradual turning of the heavens. A bright star that rested above a distant hill now stands slightly higher. Another has begun its slow descent toward the western horizon. The movement is gentle enough that it can easily be overlooked, yet steady enough that it never fails. Ancient observers learned that certainty does not always arrive through dramatic events. More often, it grows from small changes repeated faithfully over many nights. A single evening offers an impression. 100 evenings offer a pattern. 1,000 evenings begin to reveal the quiet architecture of the sky itself. Imagine a broad plain stretching beyond sight, covered with grasses that whisper softly whenever the wind passes through them. The day's warmth has faded into cool air, and above the plain, the stars seem brighter than any modern city can easily remember. Without electric lights, without aircraft crossing overhead, without distant highways, the darkness becomes complete enough for every familiar constellation to emerge one after another. The longer your eyes remain in the darkness, the more stars quietly appear. Modern science explains this gentle transformation. As our eyes adapt to low light, specialized cells, called rods, gradually become more sensitive, allowing us to perceive fainter sources of light. Ancient people could not have described the biology inside the human eye, yet they understood the experience perfectly well. They knew that patience itself seemed to brighten the heavens. Sometimes seeing more simply requires waiting. Far beyond those distant stars, galaxies continue their own silent journeys through space, separated by distances almost impossible to imagine. Ancient astronomers knew nothing of galaxies as we understand them today. Yet, they observed the same faint ribbon of the Milky Way that stretches overhead tonight. They wondered what that pale band might be, offering explanations rooted in their own cultures, landscapes, and beliefs. Today, we know that we are looking along the crowded plain of our own galaxy, where immense numbers of stars overlap until they merge into a soft glow. The explanation has changed over thousands of years, but the experience remains remarkably similar. Standing beneath a truly dark sky still inspires the same quiet feeling of being surrounded by something vast and enduring. Knowledge deepens wonder without replacing it. Over many generations, people began assigning names to especially bright stars. A name made a distant light easier to remember and easier to discuss with others. It allowed observations to become shared rather than solitary. Although the names differed between cultures, the act itself reflected an important scientific instinct to recognize recurring objects and speak about them consistently. Naming is one of humanity's oldest ways of paying attention. Across the dry landscapes of ancient Mesopotamia, the horizon stretched far into the distance, creating ideal conditions for watching celestial objects rise and set. Clear skies often revealed subtle movements that might remain hidden elsewhere. Scribes patiently recorded observations onto clay tablets using wedge-shaped marks pressed into soft surfaces. Once baked by the sun or by fire, many of these tablets survived for thousands of years, quietly preserving moments of careful observation long after the observers themselves had returned to the earth. There is something deeply peaceful about that continuity. A person pauses beneath the stars, notices a familiar planet, records a simple observation, and then continues with ordinary life. Thousands of years later, another person reads those same marks and realizes that two human beings, separated by immense stretches of time, have looked toward the very same sky. The stars become a meeting place across centuries. Elsewhere, along the Nile, another rhythm quietly shaped astronomical knowledge. The river rose and fell according to seasonal patterns that sustained entire communities. Certain stars appeared shortly before these annual floods, allowing careful observers to anticipate changes that would soon transform the landscape. Astronomy became not only an exploration of distant lights, but also a practical companion to life beside the water. The relationship between sky and earth became gently intertwined. A star rising before dawn did not simply decorate the heavens. It carried information about the seasons, about planting, about travel, about the slow turning of the year itself. The night sky became a calendar written in light, one that required no paper and no ink, only attentive memory. Memory, after all, was among humanity's earliest scientific instruments. Long before libraries gathered written knowledge into great collections, memory carried observations across generations. Stories helped preserve details that might otherwise fade. Songs repeated the order of constellations. Ceremonies marked the return of important celestial events. Elders corrected small mistakes before they became larger ones. In this way, astronomy remained alive within communities rather than existing only in objects or buildings. Knowledge was shared beneath open skies. Imagine now a quiet coastline where gentle waves roll steadily toward the shore. The moon has nearly reached its fullest phase, and its reflection stretches across the water like a path of trembling silver. A small group sits together in silence, occasionally pointing toward the eastern horizon where familiar stars begin their nightly ascent. There is no urgency in their conversation. Long pauses settle comfortably between observations. Silence, too, can be part of learning. Modern astronomy often relies upon enormous telescopes, orbiting observatories, and powerful computers capable of processing unimaginable amounts of information. Yet, beneath all of that remarkable technology remains the same simple act that connected every ancient observer to the universe. Looking carefully, the tools have become more sophisticated. The curiosity remains quietly familiar. As the seasons passed, observers noticed that the sun itself followed a changing path across the sky. During summer, it climbed higher above the horizon, bringing longer days and shorter nights. During winter, it remained lower, allowing darkness to linger. These changes unfolded so gradually that they were almost impossible to perceive from one day to the next. Yet over an entire year, they formed one of the most dependable rhythms in nature. Today, we understand that this pattern arises because Earth's axis is tilted by about 23.5 degrees as our planet travels around the sun. Ancient observers did not know the underlying geometry, but they measured its visible effects with impressive accuracy. Observation often arrives before explanation. Some communities marked these seasonal turning points by placing carefully positioned stones, wooden posts, or buildings so that sunlight would align with them during particular days of the year. Current archaeological evidence suggests that many ancient monuments incorporated deliberate astronomical alignments, although researchers continue to investigate the precise purposes of some sites. In many cases, the changing light itself became part of the architecture, quietly connecting human craftsmanship with celestial motion. Imagine dawn arriving after the longest night of winter. The air is still and cold. Frost rests upon grasses and stones. Slowly, the first rays of sunlight emerge exactly where generations expected them to appear, slipping between carefully placed markers before spreading across the waiting landscape. Those present need no spoken confirmation. The light itself gently completes the observation. Some experiments take an entire year to repeat. The moon, meanwhile, continues its patient journey among the constellations. Each evening, it appears slightly farther east than the night before, wandering across the familiar backdrop of stars. Ancient observers learned these movements so well that they could often predict where the moon would be found after sunset simply by remembering the date within its cycle. This quiet predictability brought comfort. The heavens were not random. They possessed order. That order invited understanding. Even when unusual events appeared, a bright comet, a meteor shower, or an eclipse, they stood out precisely because the ordinary rhythms of the sky were so dependable. Modern science explains these phenomena through celestial mechanics and orbital motion. Ancient cultures interpreted them in many different ways, yet all agreed upon one essential point: these rare events deserved careful attention. Scientists today continue that same tradition. When something unexpected appears in the sky, observatories around the world quietly begin observing, measuring, comparing notes, and asking careful questions. The methods have evolved, but the spirit remains remarkably ancient. Patient observation continues to be one of humanity's greatest strengths. And so another night passes. The stars wheel almost imperceptibly overhead. The moon climbs a little higher. The wind softens across the open land. Somewhere long ago, an observer quietly finishes another evening of watching, unaware that thousands of years later, others would still be following the same gentle lights, asking many of the same enduring questions beneath the same patient sky. As another quiet season unfolded, the familiar constellations slowly gave way to others, almost without anyone noticing the exact evening when the change occurred. A hunter that had watched over the winter nights gradually settled toward the western horizon, while new arrangements of stars rose patiently in the east. The transformation was never abrupt. The sky preferred gentle transitions, allowing every season to arrive with remarkable kindness. For ancient observers, these slow changes became reliable companions. There was comfort in knowing that no constellation disappeared forever. It simply rested below the horizon for a time before returning months later, as though completing a long and peaceful journey around the world. Modern astronomy explains this yearly cycle through Earth's orbit around the sun. But to those standing beneath the open sky, the heavens seemed to breathe with the rhythm of the seasons themselves. The longer one watched the sky across many years, the more it began to resemble a familiar landscape. Just as forests reveal different flowers in spring and different leaves in autumn, the heavens quietly offered different stars throughout the turning of the year. Every season possessed its own gentle character. Some evenings welcomed brilliant constellations filled with bright stars, while others carried broad stretches of softer, fainter lights that seemed to encourage even deeper silence. No season hurried the next. The sky understood patience long before humanity gave it a name. Imagine a quiet hillside overlooking a wide valley. Below, a river winds through the darkness, reflecting only the brightest stars upon its calm surface. A small fire has nearly burned down, leaving glowing embers that pulse softly whenever a light breeze passes over them. Above, the sky has become so clear that even the faintest stars begin to emerge, filling the darkness with countless distant points of light. At first, the heavens appear crowded beyond measure. Yet slowly, the eye begins to recognize familiar neighborhoods among the stars. Bright lights become landmarks. Dark gaps become pathways. Certain patterns return so often that they begin to feel almost like old friends. The human mind is remarkably skilled at finding order. Modern neuroscience suggests that our brains naturally recognize patterns, helping us navigate the world efficiently. This ability likely served our ancestors well in forests, mountains, and grasslands, allowing them to identify familiar shapes and subtle changes. When turned toward the heavens, the same tendency encouraged people to connect stars into memorable forms, making the immense complexity of the night sky easier to remember and share. The constellations are, in many ways, conversations between the universe and the human imagination. The stars themselves are separated by enormous distances. Some belong relatively nearby within our galactic neighborhood, while others shine from much farther away. From Earth's perspective, they appear side by side, though many are separated by dozens, hundreds, or even thousands of light years. Ancient observers naturally could not know these immense distances, yet they organized the visible sky with extraordinary care. Sometimes appearances provide a useful beginning, even when deeper realities remain hidden. Far across the deserts of North Africa, cool night air settled over endless sand after the intense warmth of the day. The dunes, shaped patiently by countless winds, reflected faint moonlight in soft curves that seemed almost like waves upon a silent ocean. Travelers crossing these landscapes often depended upon the stars for direction. In places where familiar landmarks disappeared beneath shifting sands, the heavens remained steady. The stars became companions that never wandered from memory, even while the dunes slowly changed beneath them. One particularly dependable guide was the star we now call Polaris, the North Star. It appears close to the North Celestial Pole, remaining almost fixed, while the rest of the sky seems to revolve around it. However, ancient observers several thousand years ago did not see Polaris exactly where we see it today. Because Earth's axis slowly changes direction over a cycle lasting about 26,000 years, a motion known as axial precession, the identity of the nearest pole star changes gradually over long spans of history. This movement is so slow that no single lifetime easily notices it. Entire civilizations rise and fall, while Earth's axis quietly traces its enormous circle through space. The stars seem eternal to us, yet even they participate in changes that unfold across deep time. The universe often measures time differently than we do. Imagine generations of one family returning to the same quiet hill each year. A grandparent teaches a child where certain stars rise. Many decades later, that child returns with children of their own, pointing toward the same familiar lights. Over a single human lifetime, almost everything in daily life may change, yet the sky appears reassuringly constant. Only over thousands of years does its deeper motion slowly reveal itself. Patience sometimes extends beyond individual lives. Elsewhere, beneath forests where tall trees framed narrow windows of open sky, observations unfolded differently. Here, the canopy limited broad views of the horizon, encouraging attention towards smaller portions of the heavens. Gaps between branches became natural observatories, each revealing a slowly changing section of the celestial sphere. The environment shaped the questions people asked. Those living beside oceans noticed the stars reflected upon calm water. Those crossing deserts watched clear horizons. Those dwelling among mountains observed the sky rising above distant peaks. The same universe gently met each landscape in its own way. Modern astronomy continues to benefit from this relationship between place and observation. High mountains offer thinner, steadier air for telescopes. Dry deserts reduce atmospheric moisture that can blur distant light. Even today, some of the world's great observatories stand where nature quietly provides especially favorable conditions. The partnership between earth and sky has never truly ended. As midnight deepened, another quiet phenomenon occasionally revealed itself. A faint streak crossed the darkness for only a heartbeat before disappearing completely. To ancient observers, These brief flashes inspired many different stories. Today, we understand that most meteors are tiny fragments of rock or dust entering Earth's atmosphere at tremendous speed. Friction heats the surrounding air until it glows, producing the familiar streak of light before the small particle is consumed high above the ground. Though the event lasts only a moment, its journey may have begun millions or even billions of years earlier. A grain of ancient cosmic dust drifts silently through space, crosses Earth's path entirely by chance, and briefly becomes one of the brightest things in the night sky before quietly fading away. Even brief moments can carry long histories. During certain times of year, many meteors appear to radiate from the same region of the sky. These meteor showers occur when Earth passes through streams of tiny particles left behind by comets during their long journeys around the sun. Ancient observers certainly noticed these recurring displays, although the connection to comets would not become clear until much later through careful scientific investigation. Nature often repeats itself gently enough for curious minds to recognize its rhythms. Not every night rewarded observers with perfect clarity. Thin clouds sometimes drifted across the stars like slow-moving veils. Moisture gathered upon the grass. Mist rose quietly from lakes before dawn. Yet even these interruptions became part of the experience of watching the heavens. The sky was never separate from the weather. The cool breath of the earth mingled with the distant light of the stars, reminding every observer that astronomy begins not only by looking upward, but also by standing firmly upon our own remarkable planet. Imagine the final hours before sunrise. Most of the night's conversations have faded into silence. The fire has become a bed of warm ash. The air carries the fresh scent of dew, settling upon leaves and stones. In the eastern sky, darkness begins to soften almost imperceptibly. One by one, the fainter stars withdraw from view, not because they have vanished, but because the approaching sunlight gradually fills the atmosphere with scattered light. Morning arrives quietly. The stars are still there. They simply wait beyond the brightness, keeping their places with patient certainty until another evening invites them gently back into view. And somewhere, perhaps without realizing the significance of the moment, another ancient observer rises from the cool ground, carries the memory of the night's observations into the coming day, and quietly adds one more thread to the long, unbroken history of humanity's relationship with the stars. As the first light of morning spread gently across the eastern horizon, the stars slowly dissolved into the growing brightness. They did not truly disappear, of course. They remained where they had always been, their distant light simply overwhelmed by the much closer brilliance of our own sun. Ancient observers could not yet describe the scattering of sunlight through Earth's atmosphere, but they understood the familiar rhythm. Every dawn quietly concealed the heavens, and every evening patiently returned them. There is a certain reassurance in cycles that ask for nothing more than time. The people who studied the sky thousands of years ago did not think of themselves as standing at the beginning of astronomy. They were simply paying attention to the world around them. They watched because the seasons mattered. They watched because travel depended upon familiar stars. They watched because the moon changed, because eclipses were rare, because bright planets wandered in unexpected ways, and because the quiet beauty of the night invited careful observation, almost without effort. Curiosity often begins as a gentle habit. Imagine a village waking before sunrise. Thin smoke rises from cooking fires. Birds begin their first songs from the branches of nearby trees. Dew rests upon grasses, catching the early sunlight in countless tiny reflections. The people who spent part of the night watching the heavens now return to ordinary work. Some walk toward fields. Others mend fishing nets beside calm water. Children gather around elders who quietly continue stories interrupted by sleep. The stars have disappeared from view, but they remain present in memory. A conversation about the sky does not always happen beneath the sky itself. Across the ancient world, observations accumulated slowly. One generation remembered where a bright star first appeared before harvest. Another noticed that the date shifted slightly over many lifetimes. Such changes were far too gradual for any one person to fully understand. Yet careful traditions preserved these subtle observations, allowing knowledge to stretch beyond individual experience. Modern science now knows that some of these long-term changes arise from Earth's slow axial precession, while others reflect the complex motions of the moon and planets. To the ancient observer, they were simply part of the sky's quiet mystery, inviting further attention rather than immediate explanation. Not every question needs an immediate answer in order to be worth asking. As evening returned once again, familiar colors gradually faded from the landscape. Greens softened into gray. Rivers became ribbons of dark glass. Hills dissolved into gentle silhouettes against the remaining glow of twilight. Above them, the first stars emerged one by one, always beginning with the brightest. This sequence itself contains beautiful science. The brightest stars become visible while the sky is still filled with scattered sunlight. As darkness deepens, fainter stars slowly appear until thousands can be seen from places free of artificial light. The universe seems to unfold in careful layers, revealing more detail to those who remain a little longer beneath the evening sky. Patience allows the universe to introduce itself gradually. Among the earliest stars to appear might be Arcturus, Vega, Sirius, or Capella, depending upon the season and the observer's location. Each shines because it is either especially luminous, relatively close to Earth, or both. Ancient cultures knew these stars well, though often by different names, weaving them into stories, calendars, and navigation traditions that reflected their own landscapes and histories. Though languages changed, the stars themselves remained faithful companions. Far from villages and cities, shepherds often became remarkably familiar with the night sky. Their work carried them into open fields where darkness settled deeply after sunset. Long hours spent quietly tending animals naturally encouraged observation. Without clocks, the changing positions of stars could even suggest the passing hours during the night. The heavens became both calendar and clock. Imagine lying upon a gently sloping hillside after the day's warmth has faded. The ground still holds a little heat from the afternoon sun. Above, the Milky Way stretches from horizon to horizon in a pale, luminous band. No sound reaches you except the distant rustle of grasses and the occasional call of a night bird somewhere beyond the darkness. The stars appear almost close enough to touch. Yet modern astronomy reminds us that nearly every point of light visible overhead lies unimaginably far away. Even the nearest star beyond our sun, Proxima Centauri, is more than 4 light-years distant. Many bright stars seen by ancient observers are hundreds of light-years away, meaning the light entering human eyes tonight began its journey long before many events of recorded history had taken place. To look upward is quietly to look backward through time. Ancient people could not measure these extraordinary distances, but they sensed that the heavens belonged to a scale unlike anything on earth. The stars neither rose from mountains nor floated among clouds. They occupied a realm that seemed permanent, distant, and serene. That intuition, though incomplete, carried a quiet truth. The universe truly is vast beyond ordinary experience. Slowly, observers noticed another gentle distinction among the stars. Most twinkled noticeably, while the brighter planets often shone with steadier light. Today, we understand that twinkling results from turbulence in Earth's atmosphere bending starlight by tiny amounts. Because stars are so distant, they appear almost as perfect points of light, making them especially sensitive to atmospheric motion. Planets appearing as slightly larger disks are less affected and often seem calmer to the eye. Even the air above us participates in astronomy. Invisible currents, rising and falling through the atmosphere, quietly shape the appearance of the night sky. The heavens and the earth are never entirely separate. Every observation passes through our atmosphere before reaching us. Science often reveals connections where earlier generations saw only distance. Elsewhere, along rugged coastlines, sailors prepared for long voyages beneath those same familiar stars. Before magnetic compasses became widespread, navigation relied heavily upon celestial landmarks. Experienced navigators learned which stars remained near the northern horizon, which rose before dawn during certain seasons, and which marked directions across open water. The sea itself offered few permanent reference points. The stars became the map above the map. Picture a small wooden vessel resting upon calm water. Gentle waves lift and lower it with slow, regular motion. The sails hang quietly in the cool night air while the crew studies the sky. Reflections shimmer across the surface, breaking and reforming with every ripple. Overhead, the constellations appear almost brighter than those mirrored below. The ocean carries no roads. Yet beneath the stars, people found their way across immense distances. Modern satellite navigation now guides ships with astonishing precision. But those systems ultimately rely upon careful measurements, mathematics, and astronomy developed across many centuries. Even today's most advanced technology carries within it echoes of those quiet nights when direction came from memory and the patient observation of the heavens. Progress rarely abandons its earliest foundations. It simply builds gently upon them. As midnight approached once more, the familiar silence returned. Wind drifted softly across open land. Owls called from distant trees. Somewhere, water continued its slow journey toward rivers and seas, reflecting fragments of starlight along the way. Above everything, the sky continued exactly as it had the night before. The stars neither hurried nor hesitated. They followed paths shaped by gravity, motion, and time itself, entirely indifferent to the passing of kingdoms or generations. Yet somehow, that indifference has always carried a strange comfort. The universe asks nothing of us except that, from time to time, we look up. And so another patient evening settled over the ancient world, bringing with it familiar constellations, wandering planets, and the quiet invitation to observe once again, not in search of excitement, but in appreciation of the slow, dependable beauty that has unfolded above every human life for countless thousands of years. As the night settled more deeply across the landscape, the air became cooler still. Stones that had gathered warmth throughout the day slowly released it back into the darkness, while gentle breezes carried the quiet fragrance of distant pine forests, dry grasses, or salt from the sea, depending on where one happened to stand. The sky above remained unchanged by these earthly details, yet somehow every place seemed to experience the heavens in its own distinctive way. A mountain offered one kind of night, a river offered another, a desert another still, yet the stars patiently watched over them all. High among the mountains, the atmosphere often became thinner and clearer. Modern astronomers continue to build observatories upon lofty peaks because there is less air to disturb incoming starlight. Ancient people may not have understood the physics of atmospheric turbulence, but they certainly noticed that some places seemed to offer unusually brilliant skies. On clear winter evenings, when the air had become especially calm and dry, the heavens appeared almost astonishing in their clarity. The Milky Way no longer resembled a simple pale band. Instead, it unfolded into countless delicate textures, dark lanes winding through luminous clouds of distant stars. To the unaided eye, these darker regions might appear to be empty spaces. Today, we know they are often immense clouds of interstellar dust, gently blocking the light from stars beyond them. Even darkness, it turns out, possesses its own quiet structure. Far beyond those clouds, new stars continue to form. Within cold regions of gas and dust, gravity slowly gathers material over millions of years. Temperatures gradually rise until nuclear fusion begins, and another star quietly joins the galaxy. This process unfolds so slowly that no human lifetime can witness a single star being born from beginning to end. The universe is in no hurry. Its greatest creations often require spans of time almost impossible for us to imagine. Imagine an elder sitting beside a young child beneath an exceptionally clear sky. The child asks why some stars seem brighter than others. The elder considers the question for a moment before offering the best explanation available within the knowledge of the time. Perhaps the brightest stars are closer. Perhaps they belong to powerful spirits. Perhaps they mark important stories remembered by the community. The answer may not align with modern astronomy, yet something equally important is taking place. A question has been welcomed. Curiosity has been encouraged. Another generation has learned that the sky is worth noticing. Scientific understanding grows most naturally where questions are allowed to rest peacefully. Modern astronomy tells us that a star's brightness depends upon several factors. Some stars appear brilliant because they are relatively near to Earth. Others remain visible despite enormous distances because they produce vastly more light than our own sun. A few combine both qualities, shining with quiet confidence across the darkness. Yet to ancient observers, brightness carried practical meaning more than physical explanation. The brightest stars became reliable landmarks. They were easier to recognize, easier to remember, easier to teach. Memory itself shaped the map of the heavens. Over many generations, certain groups of stars became woven into seasonal traditions. Their appearance before dawn or shortly after sunset gently marked familiar moments in the yearly cycle. A constellation returning to the eastern horizon might suggest that cooler weather was approaching. Another might quietly announce the beginning of warmer days. The stars themselves did not create the seasons. They simply kept faithful company with them. This distinction is subtle, yet important. Ancient observers were remarkably skilled at recognizing relationships within nature. They understood that certain celestial events consistently accompanied changes upon Earth, even if the deeper causes remained unknown. Modern science explains these relationships through Earth's orbit around the sun. But the observations themselves required remarkable patience and accuracy. Sometimes careful observation arrives centuries before complete explanation. Elsewhere, deep within broad forests, the night possessed its own gentle rhythm. Moonlight filtered through leaves, creating shifting patterns upon the forest floor. Small streams reflected fragments of the sky between moss-covered stones. Somewhere in the darkness, insects continued their endless chorus, while unseen animals moved quietly through the undergrowth. Only occasional openings between the trees revealed broad stretches of stars. Those windows into the heavens became especially precious. One did not need to see the entire sky to appreciate its beauty. A single bright planet above the treetops could inspire quiet reflection. One familiar constellation framed between ancient branches could become a lifelong companion. The universe has always been generous, even in small glimpses. Across wide grasslands, however, the horizon seemed almost limitless. There, the dome of the sky stretched uninterrupted in every direction. As the hours passed, constellations rose together in graceful arcs before descending once more toward the opposite horizon. To an attentive observer, the motion became almost musical, not because the stars made sound, but because their movements possessed rhythm. Each constellation entered the sky at its appointed season. Each planet followed its slower path. The moon completed its familiar cycle. The sun returned every morning. The heavens repeated their great composition, night after night, with extraordinary consistency. The universe often expresses order through repetition. One evening, perhaps after many months of observation, someone noticed that Mars no longer seemed to move steadily eastward among the stars. Instead, it slowed, paused, and gradually appeared to drift backward before eventually resuming its original direction. This curious motion puzzled observers across many civilizations. Today, we call it retrograde motion. Modern astronomy explains it as an effect of perspective. As Earth, traveling along its own orbit, overtakes Mars, the more distant planet appears to reverse direction temporarily against the background stars. Mars itself never truly turns around. The apparent reversal arises entirely from the changing viewpoint of our moving planet. It is a gentle reminder that appearances sometimes depend upon where we stand. Long before this explanation became possible, ancient astronomers carefully documented the phenomenon. Rather than dismissing it because it seemed confusing, they continued observing. Again and again, year after year, their willingness to trust careful measurement, even when understanding remained incomplete, represents one of the quiet foundations of science. Observation asks only for honesty. Explanation may come later. Imagine another calm evening beside a broad river flowing almost silently toward the sea. The current carries scattered reflections of stars downstream, stretching them into shimmering lines that break apart and reform with every gentle ripple. A child watches these reflections and wonders whether the stars themselves are moving with the water. An elder smiles softly. No, perhaps they reply. The river moves beneath them. Centuries later, modern astronomy would reveal another beautiful truth. The stars are moving as well. Every star within our galaxy travels through space, each following its own long path shaped by gravity. Their distances are so immense that these motions become noticeable only over many thousands of years. To human eyes, the constellations seem fixed. Yet given enough time, even those familiar patterns slowly change. Nothing in the universe remains completely still. Some things simply move with extraordinary patience. The thought need not feel unsettling. On the contrary, it offers a quiet sense of belonging. Earth turns. The moon circles Earth. Earth circles the sun. The sun circles the center of the Milky Way. The galaxy itself continues its long journey through the cosmos. Every motion unfolds according to the same gentle physical laws. No rushing, no hesitation, only the steady unfolding of time. As midnight gradually yielded to the quieter hours before dawn, the air became almost perfectly still. The fire had long since faded into cool gray ash. Dew gathered upon leaves and grasses, each tiny droplet reflecting the stars above like miniature mirrors scattered across the landscape. For a brief moment, it seemed as though the heavens existed both overhead and beneath one's feet. The same constellations shimmered softly in countless drops of water. The same moon rested upon the surface of a quiet lake. The same distant light that had traveled for years, centuries, or even millennia now completed its journey in silence. Ancient observers could never have known exactly how far that light had traveled, yet they sensed its quiet significance. Standing beneath such a sky, surrounded by darkness and gentle stillness, they became part of a tradition that has never truly ended. Even now, whenever someone pauses beneath a clear night, looks upward without hurry, and allows curiosity to arrive naturally, they are sharing something with those forgotten observers from thousands of years ago. The centuries between them grow surprisingly small. The stars have always known how to connect distant lives with the simple act of looking up, and above the sleeping world, they continue their patient journey, just as they always have, asking nothing more than another quiet night and another thoughtful pair of eyes. The quiet hours before dawn possess a character unlike any other time of night. The world has settled into a profound stillness. Even the wind seems content to rest for a while, leaving lakes smooth as polished stone and forests wrapped in an almost tangible calm. Above, the stars continue their slow procession with the same unhurried confidence they have carried for billions of years. To an ancient observer, these final hours of darkness were often among the clearest. During the day, sunlight warms the ground, causing rising currents of air that gently disturb the atmosphere. After midnight, as the land cools, the air often becomes steadier. Modern astronomers appreciate these conditions because calmer air can produce sharper views of the heavens through telescopes. Long before telescopes existed, careful skywatchers simply noticed that some nights seemed unusually clear, as though the universe had quietly polished its own windows. Nature rarely announces these moments. It simply offers them. Imagine a small gathering seated upon smooth stones overlooking a broad valley. Their fire has diminished to a bed of glowing embers that cast only the faintest amber light upon nearby faces. Conversation has gradually become less frequent. No one feels the need to fill the silence. Instead, everyone watches. One person notices a familiar constellation nearing the western horizon. Another points quietly toward a bright planet rising in the east. No excitement follows, only recognition. The sky has kept another promise. Throughout history, many discoveries have begun with nothing more dramatic than noticing that something familiar behaved just a little differently than expected. A star appeared where none had been remembered before. A planet lingered longer in one constellation than anticipated. The moon crossed unusually close to a bright star. Each observation invited another evening of patient watching. Science often advances through gentle surprises. Far to the south, beyond the experience of many northern civilizations, different constellations circled the sky. Travelers moving between regions gradually encountered unfamiliar stars, realizing that the heavens themselves changed with latitude. Today, we understand why. Earth is a sphere, and as one travels north or south, the angle from which the sky is viewed slowly changes. Some stars sink below the horizon forever, while entirely new constellations quietly rise into view. To ancient travelers, this realization must have carried a deep sense of wonder. The world was larger than any single horizon, and the sky, too, possessed hidden landscapes waiting beyond distant journeys. The heavens were not only a roof above the earth, they were a world that unfolded with travel. Imagine a caravan crossing an immense desert over many weeks. During the day, the sun guides direction across rolling dunes whose shapes are constantly reshaped by the wind. At night, when the air becomes pleasantly cool, the travelers pause beside a small camp. The darkness here is extraordinary. Without villages nearby, without lamps or fires beyond their own, the stars seem almost innumerable. The Milky Way arches overhead with such brightness that it casts a faint, ghostly glow upon the sand itself. Modern measurements reveal that under exceptionally dark skies, the combined light of the Milky Way is indeed sufficient to create a subtle illumination, allowing careful observers to distinguish shapes around them. The galaxy becomes more than something to admire. It becomes part of the landscape. The desert, the stars, and the quiet air seem woven together into a single peaceful experience. Elsewhere, beside calm seas, another group of observers waits for the rising of a familiar star just before dawn. They have seen it return every year for as long as anyone remembers. Its appearance signals that another season is quietly approaching. Modern astronomy calls this a heliacal rising, the first visible appearance of a star in the eastern sky shortly before sunrise, after a period during which it was hidden by the sun's glare. Although the term itself is modern, the observation is ancient beyond measure. Entire calendars were gently organized around these dependable celestial events. What appears to us as a beautiful morning sky also served as a remarkably precise natural clock. The universe has always kept excellent time. Slowly, careful observers also became aware that eclipses followed patterns. A lunar eclipse transformed the familiar moon into a dim copper-colored sphere. A solar eclipse briefly turned day into an uncanny twilight. Such events naturally inspired awe across many cultures. Today, we understand that eclipses occur because the sun, earth, and moon occasionally align with remarkable precision. Yet, even with this knowledge, watching an eclipse remains a deeply moving experience. Scientific explanation has never diminished the quiet beauty of celestial events. It has simply revealed the elegant geometry beneath them. Ancient astronomers gradually recognized that eclipses eclipses were not entirely unpredictable. In Mesopotamia, especially, generations of careful record-keeping eventually revealed repeating cycles, allowing some eclipses to be anticipated with surprising accuracy. This achievement did not emerge from a single brilliant insight. It emerged from centuries of observation. One person recorded, another preserved, a third compared, a fourth noticed a subtle pattern. Knowledge accumulated almost invisibly, much like stars appearing one by one after sunset. Imagine shelves lined not with books, but with carefully shaped clay tablets, each carrying observations pressed into soft earth while it was still damp. One tablet records the appearance of Venus, another notes an eclipse, another describes an unusually bright comet. Individually, each observation seems modest. Together, they become one of humanity's earliest scientific archives. There is something quietly beautiful about knowledge preserved in clay. Earth itself became the memory of the sky. Meanwhile, the moon continued its familiar cycle, never repeating exactly the same path from month to month. Its orbit is slightly tilted relative to Earth's path around the sun, a detail that explains why eclipses remain relatively uncommon. If the two orbital planes aligned perfectly, eclipses would occur every month. Instead, the geometry is just different enough to make them special without making them exceedingly rare. Even small angles can shape the rhythm of the heavens. Far beyond the moon, Jupiter shines steadily against the darkness. To ancient observers, it appeared as an unusually bright wandering star. Through modern telescopes, we now know it is a giant world more than 11 times Earth's diameter, wrapped in immense cloud bands and accompanied by dozens of moons. Yet even without magnification, Jupiter offered something valuable: consistency. Its slow movement allowed careful observers to trace its progress across the constellations over many months. The planets taught patience. They refused to reveal their stories quickly. Night after night, they advanced only a little. Their lessons belonged to those willing to return again and again. Perhaps this is one reason astronomy has always encouraged humility. No single evening is enough. No single lifetime is enough to witness every celestial cycle. Each generation inherits observations from those before it and quietly adds its own. The work is never truly finished, and perhaps it does not need to be. As the eastern horizon gradually brightens once more, the faintest stars begin to disappear into the growing light. The brightest planets linger a little longer. Venus, if present, glows softly against the pale blue of approaching morning. Birdsong slowly replaces the quiet sounds of the night. Mist rises from rivers. The first warmth of the coming day gently touches the stones that cooled beneath the stars. Another night of observation has come to its peaceful close. Nothing dramatic has happened. No great revelation has arrived, and yet something meaningful has quietly unfolded. The sky has been watched with care. The patterns have remained faithful. Curiosity has been gently nourished. Across thousands of years, these seemingly ordinary nights became the foundation upon which all later astronomy would patiently grow. Like the stars themselves, the greatest understanding often arrives one quiet evening at a time. Another evening arrived with such quiet certainty that it seemed almost identical to the one before. The warmth of the afternoon slowly slipped away from the stones and fields, leaving behind cool air that settled gently across the landscape. One by one, familiar sounds of daytime faded. Birds sought their resting places among branches. Insects began their patient chorus. Somewhere beyond the nearest hills, a river continued its slow journey toward the sea, reflecting the first stars as they quietly returned to the sky. For countless generations, this simple transition from day to night became one of humanity's oldest classrooms. There were no walls, no desks, no written examinations, only the patient movement of the heavens above and attentive minds below. As twilight deepened, a faint glow still lingered in the western sky. Modern astronomy recognizes this as sunlight scattering through Earth's upper atmosphere long after the sun itself has slipped below the horizon. Ancient observers may not have understood the physics of Rayleigh scattering, yet they understood something equally important. They knew that darkness arrived in gentle stages. The brightest stars always appeared first. Then came the planets. Only later did the countless fainter stars emerge from the slowly darkening blue. The universe seemed to reveal itself with remarkable courtesy, never all at once. This gradual unveiling rewarded those who remained outside a little longer. Imagine a young apprentice accompanying an experienced sky watcher for the first time. The elder does not begin with complicated explanations. Instead, they simply point toward one bright star suspended above the western horizon. "Remember this one," they might say softly. "Nothing more is needed." The following evening, the same star appears again, although slightly farther along its nightly path. After many weeks, the apprentice no longer needs guidance. Recognition has quietly become memory. Science often begins with familiarity. Long before measurements become numbers, they become experiences. Across many ancient cultures, observing the heavens was not separate from ordinary life. Astronomy was woven gently into farming, travel, storytelling, architecture, and ceremony. A farmer looked upward before planting. A navigator searched for dependable stars above calm water. Builders considered where the sun might rise during certain times of the year. Parents shared familiar constellations with children before sleep. Knowledge flowed naturally through everyday moments. There was little distinction between learning about the sky and simply living beneath it. Perhaps this explains why ancient astronomy developed with such patience. There was no expectation of immediate discovery. A season might pass before a single observation gained meaning. Years might pass before a repeating pattern became unmistakable. Entire lifetimes could contribute only a few small pieces to a much larger understanding. Yet those small pieces mattered. Like individual stars within the Milky Way, each observation appeared modest on its own. Together, they created something luminous. Modern researchers continue to admire the precision achieved by ancient observers working without optical instruments. The human eye, though limited, is remarkably capable when supported by experience and careful attention. Under dark skies, a trained observer can distinguish subtle differences in brightness, recognize tiny shifts in planetary position, and remember the appearance of familiar constellations across many seasons. The sky quietly rewards practice, not by becoming easier, but by becoming more familiar. Imagine standing beside an ancient stone circle shortly before sunrise. The great stones have rested here through countless winters and summers. Rain has polished their surfaces. Moss has settled into small cracks. Generations have gathered among them, each bringing their own questions beneath the same patient sky. The eastern horizon begins to brighten. A narrow beam of sunlight appears exactly between two carefully placed stones. For a brief moment, light and architecture become perfectly aligned. Current archaeological evidence suggests that many prehistoric monuments incorporated astronomical alignments, particularly with the sun or moon. At some sites, these alignments appear deliberate and carefully planned, while at others, researchers continue to investigate their purpose. The evidence reminds us to remain both curious and cautious. Science grows strongest when certainty is matched with humility. Not every mystery has yet been solved. Some ancient structures still keep part of their story quietly to themselves. That uncertainty need not diminish their beauty. Instead, it invites continued observation, just as the night sky has always done. Elsewhere on a quiet shoreline, waves arrive with gentle regularity. Their rhythm has remained unchanged for thousands of years. Above the sea, the moon hangs low over the horizon, appearing noticeably larger than it will later in the night. This familiar experience is known today as the moon illusion. Although the moon does not actually grow larger near the horizon, our brains perceive it differently when it is viewed alongside distant landscapes, trees, hills, or buildings. Scientists continue to investigate exactly why this illusion occurs, though several complementary explanations have been proposed involving perception and visual context. Even our own minds possess gentle mysteries. The universe is not the only thing worth observing. Sometimes, the observer also becomes part of the story. Far above the atmosphere, the moon itself continues its quiet orbit around Earth at an average distance of about 384,000 kilometers. Its gravity gently lifts Earth's oceans, contributing to the familiar rhythm of the tides. Ancient coastal communities certainly noticed these changing waters long before gravity was understood. The sea rose, the sea fell, the moon changed. Patient observers recognized that these rhythms belong together. Understanding often begins by noticing companionship. The same principle guided much of early astronomy. Certain stars appeared alongside certain seasons. The moon followed dependable phases. The planets wandered according to recognizable patterns. Nothing in the heavens seemed entirely random. Instead, The universe revealed itself as a place where order quietly emerged from careful observation. That realization carried profound consequences. If the sky followed patterns, perhaps those patterns could be learned. If they could be learned, perhaps future events could be anticipated, not controlled, simply understood. This distinction shaped the character of astronomy for centuries. The heavens were teachers rather than servants. Imagine now an evening deep in winter. The air is crisp and wonderfully clear. Every sound seems softened by the cold. Frost gathers upon wooden fences and the branches of sleeping trees. Above, the stars sparkle with unusual sharpness against a sky so dark that it seems almost infinite. Modern physics tells us that each star shines because immense pressures deep within its core allow hydrogen atoms to fuse into helium, releasing extraordinary amounts of energy. Every point of light visible overhead is, in essence, another sun. Ancient observers could not have imagined this astonishing reality. Yet, in another sense, they understood something equally meaningful. They knew the stars were places of enduring light, constant companions, reliable guides. Even incomplete knowledge can contain genuine wisdom. The night deepens further. The familiar constellations continue their slow journey toward the west. A bright planet rises in the east, announcing its presence without haste. The Milky Way stretches overhead like a pale river, flowing through immeasurable darkness. Above that glowing band lie countless galaxies invisible to the human eye, each containing billions of stars, each following its own quiet path through the expanding universe. The scale is almost beyond imagination, and yet the experience of standing beneath the night remains wonderfully simple. A person, a clear sky, a few hours of stillness. That has always been enough for astronomy to begin. As another ancient observer quietly gathers their belongings before the approach of dawn, they carry no certainty that their careful notes will matter to future generations. They simply record what they have seen. A bright star rising just before sunrise, the moon resting near a familiar constellation, a wandering planet slightly farther along its path than the previous week. Small observations, patiently gathered, carefully remembered. Like drops of water joining a river, these quiet moments of attention slowly became one of humanity's greatest scientific traditions. And overhead, the stars continued exactly as they always had, silent, steady, and endlessly willing to be observed by anyone patient enough to look upward into the peaceful darkness. Over countless evenings, the sky taught a lesson that could not easily be learned in any other way. It taught that meaningful change is often almost invisible while it is happening. A constellation shifted only a little from one night to the next. The moon seemed almost unchanged until several evenings had quietly passed. Even the wandering planets moved with such patience that their journeys revealed themselves only to those who returned again and again. The heavens rewarded consistency more than speed. Imagine a broad meadow resting beneath the gentle darkness of early summer. Tall grasses sway softly in a breeze that has traveled many kilometers across hills and quiet forests. Tiny insects drift above the field like living stars, their faint lights rising and falling among the stems. Somewhere nearby, a small stream continues its patient conversation with smooth stones, a sound so steady that it gradually becomes part of the silence rather than interrupting it. Above this peaceful landscape, the first constellation of the evening slowly emerges, not because it has just arrived, but because the sky has finally become dark enough to reveal it. There is something comforting about that distinction. Many things exist long before we are able to notice them. Modern astronomy has expanded this idea beyond anything the ancient world could have imagined. We now know that much of the universe is invisible to our eyes. Radio waves, infrared light, ultraviolet radiation, X-rays, and gamma rays all travel through space alongside visible light. Telescopes designed to detect these different forms of light reveal galaxies, nebulae, and energetic phenomena that remain completely hidden during ordinary observation. The universe has always been richer than human eyesight alone. Yet the visible stars remain enough to inspire quiet wonder. Long before instruments extended our senses, careful observation had already revealed remarkable truths. One evening, perhaps after many years of watching, an experienced observer notices that Jupiter has returned to nearly the same region of the sky where it appeared about 12 years earlier. No dramatic announcement follows, only a quiet recognition. Another great cycle has quietly completed itself. Today we know that Jupiter requires almost 12 Earth years to travel once around the Sun. Ancient astronomers could not calculate its orbit as modern scientists do, but many recognized that the bright planet followed a long, dependable rhythm. The longest cycles ask the greatest patience. Imagine how many evenings such knowledge required. A child sees Jupiter rise above the eastern hills. Years pass. The child becomes an adult. The bright planet slowly returns. By then, the observer understands something that could never have been learned in a single season. Time itself has become part of the teacher. Across the ancient world, memory often stretched beyond individual lives. Parents shared observations with children, who later shared them with grandchildren. In this quiet way, astronomical knowledge became a conversation lasting centuries. No single person possessed the entire story. Each generation gently added another chapter. There is a quiet beauty in knowledge that belongs to many lifetimes. Far away, beyond deserts and forests, beyond mountain ranges and great rivers, the same moon slowly rises above another horizon. Different languages greet it. Different traditions tell different stories about its familiar face. Some imagine a rabbit. Others see a woman carrying water. Still others recognize trees, animals, or figures from ancient legends. Yet every observer is looking at the very same world. The moon becomes a gentle reminder that shared reality can welcome many different interpretations. Modern spacecraft have revealed mountains, valleys, ancient lava plains, and impact craters across its surface. We have walked upon its dusty ground and brought small samples back to Earth for careful study. And still, when viewed from a quiet hillside at night, it retains something of the mystery that first inspired ancient observers. Knowledge and wonder continue to walk together. As midnight deepens, the Milky Way slowly climbs higher overhead. Without artificial lights, it appears astonishingly bright, stretching like a pale river from one edge of the sky to the other. Dark lanes wind through its glowing center, dividing bright clouds of countless distant stars. Ancient people often imagined these darker regions as rivers, roads, or pathways between worlds. Modern astronomy understands them as enormous clouds of cosmic dust drifting between us and the brighter star fields beyond. These clouds are not empty. Within them, gravity patiently gathers gas and dust together. Over millions of years, new stars quietly begin to form. The places that appear darkest sometimes hold the beginnings of future light. There is something quietly hopeful about that. Elsewhere, a gentle wind moves across a high plateau where stones have rested for thousands of years. The air is cool enough that every breath becomes faintly visible. The sky is extraordinarily transparent. One by one, satellites do not cross these heavens. Aircraft leave no bright trails, and distant cities do not brighten the horizon. Only the stars remain. This was the sky known to nearly every human being for most of history. It is difficult for many people today to imagine such complete darkness. Modern cities are illuminated throughout the night by countless electric lights. This glow scatters through the atmosphere, creating what astronomers call light pollution. It gently washes out the fainter stars, leaving only the brightest visible. The universe itself has not changed. Our view of it has. Yet there are still places where true darkness survives. Remote deserts, high mountains, small islands, wide oceans, protected parks where the night is carefully preserved. In these quiet places, the ancient sky still patiently waits. Imagine standing there for a while. No clock, no schedule, no destination. Only the slow turning of Earth beneath the stars. Although it feels as though the heavens are moving overhead, it is our own planet that quietly rotates once every 24 hours. Every tree, every mountain, every sleeping village, every ocean, and every person is gently carried through space by this continuous motion. We do not feel it. The movement is too smooth, too constant, too familiar. Sometimes the greatest motions are the ones we notice least. The Earth spins at remarkable speed, yet the experience of standing beneath the night remains perfectly calm. Science often reveals extraordinary realities hidden beneath ordinary experience. Imagine an elder tracing the outline of a familiar constellation with one slow hand. A child follows the gesture, carefully connecting one bright star to the next. At first, the pattern seems difficult to recognize. Then, almost suddenly, it appears. Once seen, it becomes impossible to forget. The stars themselves have not changed, only perception has. Learning often feels this way. The universe remains patient while our understanding quietly catches up. The conversation pauses. Neither observer feels compelled to speak. Silence becomes another form of attention. Somewhere in the distance, an owl calls once before the forest grows quiet again. The moon rises a little higher. The stars continue their slow journey toward the western horizon. Above them all, beyond every visible point of light, space stretches onward for distances almost beyond comprehension. Current observations suggest that the observable universe contains hundreds of billions of galaxies, each home to vast numbers of stars. Beyond the observable universe, scientists continue to investigate what may exist, recognizing that the limits of what we can see are determined by the finite speed of light and the age of the cosmos. Even modern astronomy accepts that there are horizons beyond which we cannot yet observe. The unknown has not disappeared. It has simply become more carefully defined. Perhaps that is one of the quiet gifts of science. Every answer gently reveals another question, not as a source of frustration, but as an invitation to remain curious. As the first faint suggestion of dawn begins its slow approach far below the eastern horizon, none of these immense realities disturb the peaceful stillness of the night. The stars remain serene. The earth continues its silent turning. The ancient observer and the modern observer share the same sky, separated by thousands of years, but united by the simple act of looking upward with patience. And for a little while longer, before morning softly returns, the universe continues telling its oldest story in the quiet language of light. The oldest stories written in the sky were never carved into stone. They were traced in light, repeated each night with such quiet consistency that generations came to know them almost as well as the landscapes surrounding their homes. A mountain might change with the slow passage of erosion. A river might gently alter its course over centuries. Forests would grow, fade, and grow again. Yet, the familiar procession of the stars seemed wonderfully dependable, returning season after season with calm precision. That dependable rhythm became a kind of comfort. Imagine a small settlement resting beside a broad lake. The surface of the water has become almost perfectly still after sunset, reflecting the first stars with such clarity that the boundary between sky and water begins to soften. Along the shoreline, reeds move gently in the evening breeze, creating a quiet rustling that rises and falls like a distant whisper. The people gathered nearby have finished the day's work. There is no urgency now. Some prepare simple meals. Others repair tools by the fading light. A few gradually lift their attention toward the sky as the familiar constellations begin another slow journey overhead. No formal lesson has begun, yet everyone present is learning. Children notice which stars appear first. Older observers quietly compare tonight's sky with memories carried across many seasons. No one is rushing toward a conclusion. The night itself unfolds at its own patient pace. Modern educators sometimes describe learning as building upon previous understanding, each new idea resting gently upon those that came before. Ancient astronomy followed much the same rhythm. Every observation gained meaning because earlier observations had been remembered. Knowledge was less like collecting isolated facts and more like tending a quiet garden over many years. Each evening added another small seed. Some would bloom quickly. Others would wait for decades. Far beyond the atmosphere, the moon continues its steady orbit around Earth. It travels at an average speed of just over 1 kilometer each second. Yet, from our perspective, its motion appears wonderfully gentle. If one watches carefully over the course of several hours, it slowly shifts against the background stars, carrying its familiar light across the heavens. Ancient observers noticed this graceful movement long before anyone understood orbital mechanics. The explanation would come much later. The observation came first. Science often begins by trusting the evidence of careful attention. Imagine following the moon through an entire month. A slender crescent appears low in the western twilight. Night after night, it grows broader, lingering longer after sunset. Soon it becomes a bright half-moon. Then a luminous full moon rises as the sun quietly sets, bathing hills, rivers, and forests in soft silver light. Afterward, its bright face slowly diminishes once more, returning at last to darkness before beginning the cycle again. Nothing about this journey feels hurried. The moon never seems anxious to reach its next phase. Its steady rhythm gently reminds us that change need not be abrupt in order to be profound. Meanwhile, among the fixed constellations, Saturn continues its slow and dignified path. To ancient observers, Saturn must have seemed exceptionally patient. While Mercury hurried close to the sun and Venus alternated between morning and evening appearances, Saturn drifted almost imperceptibly through the stars. Today, we know that Saturn requires nearly 29.5 Earth years to complete one orbit around the sun. A child who first noticed Saturn might become a parent before seeing it return to nearly the same place in the sky. Some celestial journeys unfold alongside human lives. Others extend quietly beyond them. Perhaps this is one reason astronomy has so often inspired humility. The heavens remind us that our own measures of time are only one small part of a much larger rhythm. Far across the world, where gentle waves meet rocky coastlines, experienced navigators quietly prepare for another voyage. During daylight, they study currents, winds, and clouds. At night, their attention shifts upward. The stars provide direction with remarkable reliability. Long before mechanical clocks or electronic instruments, experienced sailors could estimate both direction and the passing of the night by observing familiar celestial patterns. The ocean offered few permanent landmarks. The sky offered many. Imagine standing aboard a wooden vessel on calm water beneath a cloudless sky. The ship rises and falls almost imperceptibly with the gentle swell. Above, the constellations seem brighter than ever, while below, their reflections shimmer upon the dark sea. For a quiet moment, it becomes difficult to tell where the sky ends and the water begins. Both appear endless. Both invite stillness. Modern astronomy often speaks of celestial spheres, coordinate systems, and precise angular measurements. These tools allow remarkable accuracy in describing positions among the stars. Yet, beneath all of that mathematics remains an experience that has changed very little. A person stands beneath the night, looks upward, notices, remembers, returns another evening. The heart of astronomy remains beautifully simple. Elsewhere, in a wide desert where the air is exceptionally dry, the horizon stretches without interruption for many kilometers. Twilight fades slowly until darkness becomes complete. Then something remarkable happens. The zodiacal light begins to appear. It is faint and easily overlooked, a soft triangular glow extending upward from the horizon along the path of the planets. Modern science explains this delicate light as sunlight reflecting from countless tiny particles of dust orbiting the sun. Many ancient observers living beneath especially dark skies may have noticed this subtle glow, though its true nature would remain unknown for centuries. The universe often offers quiet details to those who linger. Not every beautiful phenomenon announces itself boldly. Some reveal themselves only through patience. Imagine waiting quietly as your eyes adapt fully to the darkness. At first you notice only the brightest stars. Gradually, more appear, then still more. Soon the Milky Way emerges. Finally, perhaps, the faint zodiacal light rises almost unnoticed from the horizon. The sky has not changed during these moments. Only your ability to perceive it has deepened. Learning often follows the same gentle path. The world becomes richer not because it transforms overnight, but because attention grows more careful. Somewhere nearby, a cool breeze stirs the branches of ancient trees. Leaves move softly against one another with a sound like distant rain. Small nocturnal animals continue their quiet lives beneath the undergrowth, largely unaware of the immense universe stretching above them. Life upon Earth follows its own patient rhythms beneath the wider rhythms of the cosmos. Neither interrupts the other. They simply exist together. Current scientific understanding tells us that every atom within our bodies was ultimately forged through processes that began in ancient stars. Elements heavier than hydrogen and helium were created within stellar interiors, and in many cases, scattered into space by dying stars long before our sun was born. The calcium in our bones, the iron in our blood, the oxygen we breathe, all carry histories reaching back across billions of years. Ancient observers could not have imagined such a connection. Yet many sensed, in their own thoughtful ways, that humanity belonged to the larger universe rather than standing apart from it. Modern science, in its own quiet language, arrives at a surprisingly similar feeling. We are participants within the cosmos, not visitors, not outsiders. As the hours drift onward, the eastern horizon begins almost imperceptibly to lose a little of its darkness. Only someone watching carefully would notice. The stars nearest that horizon grow slightly fainter. the brightest planets continue shining for a little while longer. The Milky Way gradually softens. Morning approaches with remarkable gentleness. It never seems to hurry the night away. Instead, light slowly fills the sky until the stars quietly withdraw from sight, waiting patiently beyond the blue. Another night of careful observation has reached its peaceful conclusion. Nothing extraordinary seemed to happen, and yet everything essential remained. The Earth completed another silent rotation. The moon continued its faithful orbit. The planets advanced a little farther along their ancient paths. The distant stars sent another night's worth of light across unimaginable distances. And somewhere, an observer carried these quiet impressions home, adding another small thread to the tapestry of knowledge that generations before and after would continue to weave beneath the same calm and timeless sky. Morning arrives without announcement. It does not arrive as an event, but as a gradual softening of darkness, a slow diffusion of light that gently dissolves the boundaries between earth and sky. The stars do not vanish suddenly. They fade in patience, as though they are simply stepping backward into a quieter place beyond perception, waiting for the next evening when they will return again, without ever having truly left. Ancient observers often began their day with this transition still fresh in memory. Some would carry fragments of the night into their work, quietly recalling where Venus stood before dawn, or how the moon had rested near a familiar cluster of stars. These impressions were not recorded in formal language, yet they remained vivid in lived experience, like echoes that linger after a sound has already ended. The sky, even when absent from view, continued to shape thought. Imagine a narrow path leading away from a sleeping village. The ground is cool beneath bare feet. Dew clings to grasses, and each step leaves a faint, temporary mark that will soon disappear as the sun rises higher. In the distance, fields begin to brighten, and the outlines of trees become more distinct against the softening horizon. Above, the last visible star fades, not because it has changed, but because the atmosphere has grown too luminous to reveal it. There is something quietly poetic in this reversal. Night does not end through force, but through accumulation of light. Darkness yields not abruptly, but gradually, as though it recognizes the gentle authority of the sun. Modern physics describes this process with precision. Scattered sunlight fills the atmosphere, and the contrast required to see faint stars diminishes. Yet the experience itself remains simple, almost tender in its execution. The universe rarely rushes transitions. Across ancient cultures, mornings often carried a sense of reflection. The night had offered guidance, orientation, and rhythm. Now, with daylight returning, attention shifted toward labor, travel, or rest after long observation. But the sky was never truly forgotten. It simply became less visible. Astronomy, in its earliest forms, was not separated from daily life. It lived within it. A farmer might recall the position of Orion before dawn while tending soil. A traveler might remember the rising of a particular star when choosing the direction of a journey. A child might ask questions about the moon while watching it pale against the morning sky, still faintly present before disappearing into daylight. Knowledge persisted not in isolation, but in memory woven into ordinary moments. Far beyond human activity, the sun continues its steady radiance. At approximately 150 million kilometers from Earth, it provides the light and energy that sustain nearly all visible life on the planet. Ancient civilizations naturally revered it, recognizing its central role in shaping seasons, warmth, and growth. Even without understanding nuclear fusion or stellar structure. Today, we know that the sun is a middle-aged star, composed primarily of hydrogen and helium, steadily converting mass into energy through processes occurring deep within its core. This energy takes thousands of years to slowly migrate outward before finally reaching space as light and heat. Yet even without this knowledge, its presence has always been unmistakable. It governs the rhythm of day and night. It shapes the cycle of seasons. It defines the visible sky against which all other celestial motions are measured. And still, the night sky retains its own quiet authority, because when darkness returns, it does so completely. Imagine now a wide valley at dusk, where shadows slowly lengthen across fields and hills. The air begins to cool, and a subtle stillness spreads across the landscape. Birds move toward their resting places, and human activity gradually softens. There is a brief moment where neither day nor night fully dominates. It is in this in-between space that the first stars return. One by one, they reappear with familiar patience, not as newcomers, but as returning presences. Modern astronomy tells us that these stars have been shining continuously, without interruption, for millions or billions of years. Their light has simply traveled across space, through vacuum, through time, through the vast distances separating them from Earth. What we see is not their arrival, but their arrival into visibility. There's a subtle difference that changes everything. Light does not arrive when it begins its journey. It arrives when it reaches a place capable of receiving it. Elsewhere, in regions far from artificial illumination, the transition from twilight to full night reveals the sky in increasing depth. First, only the brightest points are visible. Then more appear, gradually filling the darkness until the Milky Way becomes unmistakable overhead. In such conditions, the sky feels less like a surface and more like a volume, something one is inside of rather than merely looking at. Ancient observers would have known this experience intimately. They lived beneath skies that modern urban life rarely allows us to see. And yet, even today, when one finds a place sufficiently dark and quiet, the same sense returns with surprising familiarity. The sky has not changed. Only our access to it has become rarer. In that returning darkness, constellations begin to organize themselves again in memory. Patterns that once seemed complex become familiar once more. Orion's belt, the arc of Scorpius, the gentle curve of Cygnus stretching along the Milky Way each becomes a quiet anchor within the immense field of stars. The human mind, after all, is built for recognition. It finds meaning in repetition, comfort in return, and the night sky offers both without end. Far across centuries, the same constellations have been recognized under different names, in different languages, with different meanings attached to them. Yet their arrangement remains constant from human perspective. This stability allowed astronomy to become one of humanity's earliest shared sciences, even before formal institutions existed. Knowledge could be passed simply by pointing upward. The sky required no translation, only attention, only presence. As night deepens once more, a familiar calm settles over the world. Rivers continue their slow movement toward oceans. Forests breathe in rhythms too subtle for casual notice. Oceans rise and fall under the influence of distant lunar gravity. Even deserts, which appear still, experience quiet shifts as temperatures change between day and night. Everything participates in larger cycles. Everything moves within systems far greater than immediate perception suggests. And above it all, the stars continue their ancient choreography, not performing, not waiting for recognition, simply existing in motion shaped by gravity, inertia, and time. There is a quiet reassurance in this independence. The universe does not depend upon being observed in order to continue. And yet observation remains one of the ways it becomes meaningful to us. Somewhere, an ancient observer completes another night of careful watching. The notes may be simple, the memories may be imprecise, the understanding may still be incomplete, but the act itself is complete. Attention has been given, and that in itself is enough. As the final hours of night continue to unfold, the sky remains unchanged in its patient grandeur. The earth turns, the moon orbits, the planets proceed along their long paths. The distant stars continue to shine with quiet persistence across unimaginable distances. And for a little while longer, before the next dawn gently arrives, the universe continues its oldest practice, being there quietly for anyone willing to look upward without haste. The final hours of night carry a stillness that feels almost complete, as though the world has momentarily set down everything it was holding. Even the faintest sounds seem softened by distance. A leaf shifting, water moving through unseen channels, the slow settling of cool air across open ground. In this quiet interval, the sky appears less like a distant ceiling and more like a vast presence that has always been there, unchanged, patient, and calm. Ancient observers often valued these final hours most of all, not because anything dramatic occurred, but because everything unnecessary seemed to fall away. Imagine standing alone in a wide, open field. The grass is damp beneath your feet, and each step is quiet enough that it feels as though the earth is listening. Above you, the stars remain steady, though a few near the eastern horizon begin to soften as the first hint of morning approaches. The rest of the sky still belongs fully to night, deep and expansive, filled with familiar constellations arranged in their slow and silent order. There is no urgency in this transition, only continuation. Modern astronomy explains this moment as Earth's rotation gradually bringing your location back toward sunlight. The horizon does not move upward or downward. It is the planet itself turning, carrying every observer toward a new alignment with the sun. Yet the lived experience remains simple and gentle. Night does not end suddenly. It loosens its hold gradually, as though it is willing to let go without resistance. Across ancient civilizations, this gradual return of light often marked a time for quiet completion. Observations were concluded. Notes were mentally reviewed. Familiar stars were acknowledged one last time before fading from view. There was a sense of closure, but never of disappearance. The sky would return. It always did. Imagine now a small group gathered near a low stone structure, worn smooth by generations of wind and time. They are not speaking loudly. In fact, their words are few. Most communication happens through shared attention rather than speech. A hand lifts briefly to indicate a star nearing the horizon. A nod confirms recognition. A pause acknowledges understanding. In this way, knowledge becomes almost silent. It is passed through presence more than language. Modern understanding of human cognition suggests that memory is strengthened through repetition and emotional association. Ancient astronomy naturally took advantage of both. The emotional tone of night, its calm, its stillness, its sense of scale became intertwined with the act of remembering celestial patterns. As a result, knowledge of the sky was not simply intellectual. It was experiential. It was felt. Far beyond the immediate landscape, the moon continues its orbit, now moving into a phase where its presence in the sky is no longer dominant. In certain nights, it disappears entirely from view, entering what we now call the new moon phase, when it lies roughly between Earth and the sun. Ancient observers would have experienced these periods as times when the familiar nighttime companion was temporarily absent. Yet, absence in astronomy is never permanent. The moon always returns. Slowly, it reappears as a thin crescent, then grows again through its cycle, continuing its endless rhythm. This predictability, repeated across countless generations, became one of the earliest foundations for structured timekeeping. Long before mechanical clocks, the sky itself provided rhythm, not through minutes or seconds, but through cycles, day and night, lunar phases, seasonal shifts in constellations, planetary returns. Each layer of motion added a different dimension to the perception of time, creating a sense that the universe was not only vast in space, but also richly structured in duration. Imagine a traveler resting at the edge of a wide desert just before dawn. The horizon is a thin line separating darkness from the coming day. Above it, a few final stars still remain visible, though they appear fragile against the growing light. The air is cool, almost crisp, carrying the scent of stone and sand that has not yet been warmed by the sun. The traveler does not rush. There is nothing to outrun, only a moment to witness. Modern physics describes this transition as the scattering of shorter wavelengths of light by atmospheric particles, gradually filling the sky with blue. But the experience itself is less technical. It is a slow unveiling, a world gently returning to visibility, and within it, the stars fade one by one, not as loss, but as a natural withdrawal. Far away, in a different time and place, another observer might be recording the same sky, perhaps marking the rising of a particular star just before sunrise, perhaps noting the position of a planet relative to a familiar constellation, perhaps simply observing without writing anything at all, allowing memory alone to hold the experience. Not all knowledge needs to be preserved externally. Some of it lives entirely within attention. As dawn approaches more fully, the contrast between sky and earth begins to shift. Shapes become clearer. Colors begin to separate. The dark outlines of trees, hills, or buildings emerge from shadow. And gradually, the stars relinquish their presence, not because they have moved, but because light has returned to the atmosphere that surrounds the observer. There is something quietly balanced in this exchange. Night gives way to day. Day gives way to night, each holding its place without conflict, each arriving with certainty. In this rhythm, ancient astronomy found both structure and meaning. The sky was not random. It was orderly, not in a mechanical sense alone, but in a way that suggested continuity, reliability, and coherence across time. Even without understanding the physical laws behind celestial motion, observers recognized its dependability. And in that recognition, they found orientation, not only in space, but in time. As the first full light of morning finally settles across the land, the last faint stars vanish completely from view. The sky becomes a continuous field of pale blue, and the world returns to its daytime clarity. Yet nothing about the heavens has ceased. The stars remain, still shining, still distant, still moving along their ancient paths. They are simply no longer visible for the moment. And so the night concludes not with disappearance, but with continuity beyond perception. The observer turns away, carrying the memory of the sky into the day that follows. And somewhere within that memory, quietly preserved without effort, the universe continues its presence, patient, vast, and unchanged, waiting for the next evening when darkness will once again make it visible. And when that moment arrives, as it always does, the sky will begin again, without needing to remember where it left off.